Hi guys, this is Anshul and I'm going to be walking you through this specific problem on leetcode.com. And so the problem is called as toSum, as you can see on the screen. And what needs to be done is you have this array of numbers and there is a target that is given on the right hand side. And from this array of numbers, what needs to be done is that you need to find two numbers by which the total sum of those numbers has to be equal to the target number. And if that is the case, if you do find a solution, in that case we need to return the index of those specific numbers. So for example, in this case we have an array 2, 7, 11 and 15 and the target is 9, and in order to get 9 we can actually sum up 7 and 2 and we can actually get 9, right? So this program is supposed to return 0, which is the index number of 2, and 1, which is the index number of 7. Now let's look at the solution over here. So here is a solution which I have implemented, and so there are two solutions in fact. One of these solutions actually takes a lot more time, and the second solution takes pretty much less time, which is O of n. And so let me walk you through the first solution over here. Now the one that you see here is there are two for loops that we are using, and we are trying to calculate the sum of those two numbers. So essentially what we do is the first number or the first index is positioned on the first number. For example, I position my index value on this specific number, and the inner for loop will be positioned on the next number, which is 7 in this case. And so I is equal to j plus 1, so that is what it translates to. And if the sum of these two numbers is equal to the target, in that case we create another vector which is an array, and we push the index numbers of index number j and index number I, and then we return the result from this specific function. Now in this case we have two for loops, so this is going to take O of n squared time, so that's a lot of time for a solution to execute. So let's run this code quickly, and you can see the output over here. So the input is 2, 7, 11, 15. My answer is 0 and 1, and the expected answer is 0 and 1. So this is correct, right? So now what I can do is I can go ahead and submit the solution. Okay. Right, so this is accepted, but then is it really acceptable? That is something that we need to find out. So let's look at more details for this problem. And now you can see in this case there is a distribution over here, and it says between 20 to 25% of people were able to get the solution within 25 milliseconds. Okay, and my solution, which is the one with two for loops, is actually somewhere in the range of 100 and 150 milliseconds. Now this is too high for us with this specific problem. Now in order to reduce this, let's look at the second solution. Okay, and by the way, this graph also shows you exactly where you stand in terms of the speed of the execution of your problem or the function that you have wrote. So in this case I'm somewhere around 38.81% of all the other CBB submissions. Now let's go back to the solution. I'm gonna comment this out now, so let's do that. uncomment this one. Now this specific loop, as you can see, uses map as the one of the structures to initialize all our integers and the corresponding mappings. So essentially what it does in this case is we are actually calculating the target and we are subtracting it from the index number. Okay, so what that means is, in this specific case, we take the target 9 and then we subtract, for example, 2 from it. Okay, so that gives us 7, right? And then what we do is we try, so 7 is going to be stored in the complement for this specific example, and then we try to find the complement in the new map. Okay, and if there is a match and if it is not equal to new map.n, in that case we push back the index value. So in map we have this we have a mapping of the value and its index position. Okay, so we are doing it over here in this case, so it kind of it takes in the number I. So for example, if we look at 2, so that is going to be 2 over here and the index number is going to be 0. Okay, and we push in case if it matches, then we push the index number of 2, okay, which is a new map complement. This will actually return the index, and then we push back the second index, which is 7. Okay, and then we return the result. Now this is done in one single for loop, and the total running time for this particular for loop is O of n, because it runs for the total size of the input. Okay, so let's run this. And this finish, and you can see again the answer is 0, 1, and expected answer is 0, 1, right? So I submit this solution, and it's pending, and there we have it. So now if I go to more details and look at the results, now it shows this distribution and where we stand at this point. So in this case I have the runtime which actually beats 100% of other CPD submissions, right? So you can see, based on the earlier for loops, which we had 2 for loops and it was taking O of n squared time, and in this case we have a single for loop which is actually taking O of n time. And that's why our total distribution or the speed of the execution of our code is beating all the other times over here. Okay. Alright, so I hope this was helpful, and I'll be creating more of such videos. Thank you so much, and you have a good day.